Hi everybody, this lesson is about algorithms. Some of you may know what that is, some of you may not, but we'll get into those details in a moment. But first I kind of wanted to talk about why we're doing this. This is actually an add to the class, and there's two reasons why I felt strongly that we should do this. I presented it to the other instructors and they all agreed that it made an awful lot of sense. It would be quite helpful. And so, I think the others are going to be using this same slide deck. They may or may not do videos as well. I don't know. But at the end of the day, we're kind of all agreed that this is something you all need. And why? So why do you need it? Well, there's two basic reasons. Number one is a big chunk of computer science is studying algorithms, is coming to understand the efficiency and performance of particular algorithms versus others. The truth of the matter is that you can program an infinite number of ways to solve the same problem, but there are certain ways that are going to be much more efficient than others. So I saw this in real life a lot. I'd have developers that would write a piece of code just because they were familiar with the way to doing it that way. But in reality, it worked probably fine when they did their unit tests, but when they actually ran it in production on a large scale, and they're doing tens of thousands or hundreds of thousands of transactions, it was ungodly slow or inaccurate or whatever the deal was. It just didn't work the way it did when they did their unit testing. And I've seen that a lot. In fact, a good chunk of my career was about tuning those kinds of things, making them faster and everything else. And it came out of the fact that having a computer science background, I was very familiar with algorithms and the relative strengths and weaknesses, what they were good for, what they weren't good for. And so, that's one reason to do it. The other reason is probably a little bit more pragmatic and a little closer to the vest. Some of you may not go on into computer science. Regardless, what we're going to talk about in a moment is very, very useful, regardless of whether you're working on computers or not. And the reason we're going to talk about algorithms is I noticed that there was a significant number of my students in the last class that developed what I call the deer in the headlights look as we went into it. They got the basics. They didn't even get the basics. They got, like the first step. They could all write to screen, but beyond that, they struggled mightily. And so, I tried to help a number of them, and I would say, okay, so, what are you trying to get done? And, it says to do this, and I don't know where to start. Well, start at the beginning. What do you think the first thing is you should do? And if they came, they tell me, and if it was the first thing, I'd say, okay, write that down. That's the first thing you do. Then what? And, I kind of lead them through a process to do that to the extent that they were willing to spend the time to do that. I could have helped them get through and understand a little bit better. However, most of them didn't take me up on that, and they did poorly in the programming section. And if you looked at the syllabus, the programming section has a significant chunk of the points associated with this class. So you want to do well in the programming sections. You don't want to be messing them up. And it's okay. I understand that people may come in never having programmed before, and it'll seem so foreign, so unusual, that you can get that deer in the headlights look. You can really get stuck on, I don't know what to do. Well, this is what this lesson is all about. It's about how do you develop out, an algorithm for solving a problem. But let's turn to the slides real quick. So, so we're midway through the introduction. So, first of all, let's go in here. So, the goal here, my biggest goal out of this whole thing is for you to have a process to kind of get you started, to get you past that deer in the headlights situation and get you moving in a direction. You know, don't think that you've got to have it perfect when you first write it down. It's an iterative process. It's something you kind of go through multiple iterations, and you're refining until at some point it's what you need. But it's that iterative process as you think through things and organize your thoughts and develop that outline of, well, I'm going to do this, then I'm going to do this, then I'm going to do this, then I'm going to do this. That gets you over that hump of, I don't know what to do. It's all so foreign. It's all so different. It isn't. So what we're going to do is we're going to talk about algorithms, but we're not going to do programming language. We're going to talk about algorithms that happen in plain old everyday English. We're going to go into some example algorithms soon here to kind of give you an idea what that's all about. So we want you to be able to develop a simple algorithm in English that has sufficient detail that you could hand that algorithm to someone else, another student, say, for instance, and they could do the task based on your algorithm. They could get it done. Okay? So that's it. That's the basic idea. I want you to be able to do that. Now, in reality, you know, if we were sitting in a classroom, I might actually physically have you do that. I might actually have you hand your algorithm over to another student, and I'd have that student go up and demonstrate that they could do the task. Maybe, but obviously we can't do that in an online class. So who are we doing this for? Well, number one, you're doing it for yourself. If you think about writing it for someone else and you get it to sufficient detail that you could give it to someone else, you can be fairly certain that you've got enough detail in there to get the job done. The other thing is, well, you're writing it for me. I'm going to be taking a look at it, and I will play the dumb hick card if I need to sit there and say, oh, wait, I won't go that far. But in reality, I will be looking out for things where you're making assumptions, and I don't know that those assumptions are well-founded. But that's so. But in reality, this is really all about you. It's not about me. It's about getting you a process that you can develop. So one of the things I talk about is that an algorithm is writing an algorithm to prepare for writing a program is not unlike writers and how they prepare. If you ever read writers talking about the writing process, in general, what they generally talk about is, okay, I start with an outline. I know these big things have to happen in this order for the story or the message to develop. And then as they dig in, as they get to those big things, they start to break the big things into smaller things and figure out what that order is and how things have to happen and which character talks to who, and did I introduce this character already, and all that kind of stuff. So they begin to resolve those things, and they'll do that to some point, at which point they feel like they can write. And then they'll get into the description of the scene that they have in mind. It's only been, it's only been summarized so far in their outline. Very similar to what we're doing here. So whenever I'm think about the meaning of something, I generally start with the dictionary as a good place to start. And so I went to the Merriam-Webster online dictionary and found this. It is an algorithm, a procedure for solving mathematical problems as a finding the greatest common divisor in a finite number of steps that frequently involves repetition of an operation. Well, that's a ton of words, and I like to keep things simple. And I actually like the next piece a lot better. And so what they said there is, broadly, a step-by-step procedure for solving a problem or accomplishing some end. And I like that a lot better because you notice it doesn't say anything about mathematics in there. It doesn't necessarily indicate that you're going to have to do things over and over and over again. May not necessarily be the case. Oftentimes it is, but not always. So, let's look at some examples. All right, so here's an example. This is a screenshot I took off of the used to be the Immigration and Naturalization Service. Now it's called ICE, and I forget what that stands for. But at the end of the day is I went out to their website and stumbled around and found this immigrant visa process. We see it shows two things. It shows that there's 12 steps and what those steps are. And also notice that they indicate the order in which they're done. Now, step 1, 2, 3, 4 would probably, be a big clue anyway. But at the end of the day, you also notice there's little arrows in there that show that this step happens before that step. And again, these are things I'm going to repeat multiple times. So it's always a big clue when you hear me repeat them multiple times. An algorithm has to do two things. It has to list the steps that have to be completed, and it has to provide the order in which these things are completed. A lot of people understand the steps, but they don't pay close enough attention to the order. So keep that in mind. Now, if you look at this, certainly one of the first things that you're going to be thinking is, well, some of this is extremely high level. Financial documents. What financial documents? Where do I get them? Online application. Okay. What do I need to have to complete that online application? Civil documents. What the heck are civil documents? What are those, and where do I get those? And on and on and on. I would tend to think that in just almost any, even the step one, submit a petition. What's a petition look like? And who do I submit it to? So clearly, there's lots of detail that's missing in this. But you get a general idea, a high-level summary of what happens in order to get a visa. Okay, and that's fine. Let's look at another. One. Now, this is more technical, and this is more along the lines of what you're going to be doing ultimately. Why we're learning this process now. And that is, you notice that these are very specific technical things, and many of these things you may not understand right at present time, and that's fine. I don't expect you to. We've got a few weeks before we get into that, but at some point in here, you're going to understand many of the things that are talked about in here. But you see that here's your first step. What's the first step, second step, third step, fourth step, fifth step, right? Again, what are the steps? What are the order? So why are algorithms important? Well, I always come back with a rhetorical question of why are recipes important? Now, some of you, I know a lot of people take great pride of, I don't follow recipes. Well, that's fine. That's good for them. If they're comfortable with it, that's fine. But, basically, I'm an engineer. Heart of hearts, I'm an engineer, I'm a scientist, and I want my results to be consistent. So I follow a recipe because these are not things that I feel like I have the, when I cook, I want people to be satisfied. I want to be satisfied. I want to enjoy what I did. And so I rely on getting that information from people who have done it. And they set those things down in recipes, and they generally follow a format. Here's, you need these ingredients, and then there's step by step. Do this, then do this, then do this, then do this. And, ignore those steps in your peril, at your peril, right? Certainly, sometimes, doing one step before the other isn't such a big deal, but oftentimes it's absolutely crucial. It's absolutely crucial that you do the things in the right order. So, anyway, again, algorithms specify not only what needs to be done, but also the order in which to complete the steps. In the process of developing an algorithm. You also, as you build out these steps, that process will frequently reveal when you're going to need more information, when you're going to need, what decisions have to be made in the course of the program execution, and what kind of outputs am I going to have. Those are the kinds of things that happen as you develop this out. And it is intended to be an iterative process. It's not sit down and write out your algorithm in a single sitting with one pass. In fact, I'm going to show you an example here where kind of how that works. And it's that process of going back through it over and over and over again until you get to a point where you're comfortable with it that makes all the difference in the world. Why is it important? Well, you're going to be coding soon. And for some of you, the programs will seem to be very intimidating and overwhelming. There's so much. You're learning so much, and then you got to apply it, and you don't know where to start. What I always call the deer in the headlights lot, right? And your task is going to be a lot easier if you can break it down into more manageable steps. And this process, which when I was starting in this field, it was taught. It was part of what we were taught. And that process is called stepwise refinement. And we're going to go a little bit more detail, but stepwise refinement is a methodology for developing algorithms. And what's really interesting is stepwise refinement itself is an algorithm. So let's look and see what that algorithm looks like. So stepwise refinement, it's got 3 steps. There's 3 steps, but multiple iterations of some of those steps. So break the problem statement in major tasks, okay? I think you kind of all got that. We saw that in the immigration one, right? 12 major steps. And then for each of those steps or tasks, determine if there are subtasks that must be defined. So again, going back to the example of the immigration thing is, okay, what are the civil documents? Where do I get them? Those are things I need to understand. So in order to solve that particular problem or to go through that process. And so if that happens, then break it into the separate subtasks. Find out what civil documents there are, figure out what the source of them are, and those would be subtasks that you would develop out of that. And in fact, if you drill through the website there, it does do that. It breaks it all down. It goes in there and says, okay, these are the documents you're going to need. These are where you're going to get them. So on and so on and so on. But the important thing is you just keep doing this. You keep at each task, you take a look at it and you say, do I know everything I need to know to solve this problem right now? And if the answer is no, then you break that down into smaller things. So say, okay, what is it that I need to know? Again, when we get to the civil documents things, what are civil documents? Is the first thing I need to know. And then what are the specific civic documents I need to know? So that's 2 subtasks. Third subtask is, where do I get those civil documents? Okay, so there's at least 3 subtasks that come out of that. And, once you get the information, once you dig into that a little bit, you may find, there's even more. And so you keep doing that until you think, okay, I've got a handle on what this problem is and what I need to do and the order in which I need to do it. So here's an example of developing an algorithm. I picked this because my wife and I got a new, we like Jack Russells. We've got one that's 7 years old, and we wanted to get her a younger playmate. So we went out and got another Jack Russell dog. And so we got him as a puppy. He was 4 or 5 months old, so it's a little over a year ago now. And of course, he needed to be potty trained. And it's something you go through if you're going to raise dogs. And so, what's the process for potty training a dog? Well, at the highest level is you get that puppy, keep an eye on them, and when they need to go, you take them outside. And if they go outside and they do their business, you reward them. And you wash, rinse, repeat. You just do this over and over and over and over again. And at some point, the puppy will associate going outside with going potty, and he'll let you know that he needs to go outside, and you take him outside, he does his business, he gets rewarded, you reinforce the behavior, and pretty soon the amount of mess you have to deal with in the house drastically decreases if it doesn't go away entirely. So that's the first steps. However, there's really not a lot of detail in there. In fact, if I were to go back for just a moment and take a look at this, notice I have 24/7 and question marks. So as I'm going through this, I realize, watch the puppy closely. Well, all day, every day? Clearly that's not possible. So there's something here I'm missing. What would be the next, what could I do? So then I go to the next step. And so what I've done is I take that second step and I've broken it out. And I said, okay, watching the puppy closely requires that when two sub-steps, that when I'm awake, I keep the puppy with me. And when I'm asleep, I put the puppy in its crate. In case you're wondering what that's all about, is you do that if you haven't raised dogs and you're not aware of that. Dogs do not like to poop or pee where they sleep, just like we wouldn't like to do that either. So if you put them in their crate, they will hold it as long as they're physically able to do that. And so you put them in their crate, they'll go to sleep, and they won't, generally what happens is they'll hold on to it until you get up and you take them outside. If they need to go, then they'll probably start letting you know. They'll howl or whine or something like that and let you know they need to go, in which case you get up, you take them outside and reward them. Yes, sometimes I get up at 4 o'clock in the morning and take the dog out. I'd rather do that than train him that it's okay to go to the bathroom in the house. So anyway, so I took this second step and I broke it into 2 sub-steps. However, again, as I'm thinking this through, as I'm doing it, I thought, well, wait a minute. I said, put the puppy in his crate. Do you even have a crate? And for that matter, so it's like, okay, how do I reward the puppy? So another iteration, another round of refinement. So now I noticed that, so then I was like, okay, so I need, after I get the puppy, I got to get a crate and I got to get treats for rewards. Okay, that's, and so we see that even though originally I didn't have sub-steps for get the puppy, and in reality, are they this, anytime you get a puppy, you're going to need to get a crate and puppy treats. Well, maybe you have another dog like I did, and I had a crate and I had treats. But at the end of the day, when you're thinking it through, these are the questions that come up, and these are the places where you start to define these out. Now, that's kind of that process you keep doing. So again, we're back to, so then notice in here that finally in here I put a note in here that says, put the puppy in its crate from 12 to 8, and will the puppy stay in its crate all night? Will he sleep all night? Well, again, we could go on further. We could develop this out. But the deal about stepwise refinement is you go until you're comfortable that you have the answers you need to actually follow that algorithm out. There are points at which you go, okay, that's enough. And it's really up to you. And certainly what will happen is, as you become more experienced, your algorithms will probably be a little shorter, because you'll see a lot of repetition in programs and the like, and you won't need to develop out quite so much detail, because you go, oh, that's such and such. For instance, when I look at this as an experienced programmer, what I see here is something we call a tree. Okay? Now, trees are important data structures that we use, and they're very, very useful for things like sorting and indexing and searching. And the way you do those things are well known and understood to people like me. And so I don't I don't worry so much about it. It's like, I might simply, for me, I might simply say, put it on the tree and search the tree, take it off the tree, rebalance the tree. Those are basic things we might do. And I might not go into the details of how that's done because I already know how to do that. And that's fine. Because at the end, you're doing this for your self-defined structure. And I would expect that the more experienced you become, the smaller your algorithms will be. And sometimes you may not even bother to write that out. Because at some point it becomes almost second nature to begin to break problems down into their steps and to figure out what the order is. And sometimes that's all you need. So, anyway, now let's, now here's a detailed example, and the reason here's another detailed example. And the reason I'm introducing this now is, this is something you will see multiple times. What I plan to do is, as we go through the programming part of the class, I will build on this algorithm as you encounter new things about programming, as you understand new things about programming. Because when we look at this particular algorithm, it's simple, which is fine, which is where I want you to start. It's simple, but it's pretty limited in what it can do. It's not particularly flexible. It's not particularly useful. And as we learn some things in programming, in the programming constructs, we're going to go back and change this algorithm to reflect what we've learned and to give it more capabilities. So I'll change the project requirements. So it will be something more than just calculate the average of any three integer numbers. It'll be something more than that. So that's fine, but this is where we're going to begin. And so let's take a quick look at this. So again, as I'm building out this algorithm, it's like, okay, so how do I calculate the average of any three integer numbers? And I picked this one specifically because most of us did averages in our grade school. I'm sure you probably remember how to go about doing it. Average is simply the sum of a bunch of numbers divided by the number of numbers. That's an average. Sometimes known as the mean, I think, mean or median. I always get those confused. Anyway, upshot of it is, it's a pretty straightforward process. In this case, I just wanted to get the average of three numbers, and I'm purposely keeping it very simple to begin with. So on the second iteration down, we say, okay, so second iteration, so we got our first steps, we got to get the three numbers. So I say, well, ask for the first number and write it down on paper. Notice I'm not talking about computers. I want you to remember, algorithms are not limited to computers. They're just simply operational steps. I can tell you that a lot of the time in my information security career, a lot of what I ended up doing was writing policies and procedures that were essentially algorithms for how we do things in information security. So and those things oftentimes had nothing to do with computers at all. Information security is a lot more than just simply computers. Anyway, so here's the algorithm. Get the first number, write it down on a piece of paper. Get the second number, write it below the first number on the same piece of paper. Third number, write it below the second number, same piece of paper, right? Add the column of numbers together. Again, did I talk about the process for adding? No, because I'm assuming you all know how to add a column of numbers together. That's not a problem. Anyway, and then what I'm going to do is the result of that addition, I'm going to label it as S. And S is just simply short for sum. And then I'm going to divide S by 3, and then the result of that will be the result of dividing S by 3 will be A, the answer. Okay, so I could then write down A is equal to, in other words, the answer is A is equal to something. So that's it. That's all there really is to in this example. But as I said, as we go further into this, as we start developing more and we understand, we start to develop some of the capabilities with the programming, we learn a little bit more about programming, we're going to revisit this algorithm, and we're going to make it reflect the new knowledge that we have, and you'll understand how much more powerful the program will be at the end, or how much more useful it will be at the end than it currently is today. So with that, we're going to get into our conclusion. So again, almost any problem can be solved by this technique. Solving the problem in English is one form of what we call pseudocoding. And recall that, what we're trying to do is you need to be able to write an algorithm that you could give to someone else, and they could accomplish the task. Even though you're not going to physically be doing that, you'll be giving it to me, but you're not going to be. Keep that in mind. That's your goal. If you could write it for someone else, then it will help you organize so that when you write your program, you'll have that outline, and you'll get there a lot faster and a lot easier if you do the outline up front. And that's, in this case, the algorithm. So there is homework, and you'll look at the course content, and you're going to see that there's a homework task in there, a homework piece, whatever we call that, in there. There's a homework assignment in there. It's essentially this. And what I'm going to want you to do is take a simple task that you know how to do, break it down into tasks and subtasks and everything else to the extent that you need to, in order to feel like you could give it to someone else or give it to me, and I'd be able to do, someone else would be able to do the task successfully. Again, don't assume that other people have specialized knowledge that you have. So, don't assume that because you know how to rebuild an engine, all of us know how to rebuild an engine. Or, if you know how to torque, you know the torque values for lug nuts on your wheels, don't assume that everyone knows what torque values are used for, or how, what kind of tool you would use in order to ensure that that torque was achieved. Those are things you need to think about. So keep it simple. Again, it says somewhere between 5 and 15 steps. I don't want you to spend a ton of time on this. What I want you to do is begin training your brain to break problems into smaller parts. Anyway, that's it. I hope you get a lot out of this. Again, I know it may seem like extra work, but it's kind of one of those things. If you do the extra work up front, you're going to find what you're really trying to get done will get done a lot easier if you do it this way to begin with. So that's it for this lesson. I'll look forward to seeing you in the next one.